Hi, my name is Kirsten and I'm studying chemical engineering at Waterloo. I have an assignment to do, so let me show you guys what it is. So the project I'm working on is Milestone 4, and basically it's for the class CHE 181. It's our design course and we're doing a lot of theory with circuits, but more application of circuits as well as things with AutoCAD. So let me tell you guys exactly what I'm making. So for this assignment, we have to track temperature versus time, but we'll be using an RTD. Our course gives us everything, but specifically for this circuit, what we needed was an Arduino, an RTD, and 2 female-to-male connectors, and about 5 male-to-male that I just didn't draw. And we'll need a resistance of about 1k ohms, and using the ones that our course gives us, we need about 2 of those little resistors. So we'll be building a very simple circuit, and this is kind of what the schematic would look like. In the circuit, we have R1 and R2, and we want to find what the voltage is in between that point before the RTD. We can use Ohm's law, and of course I already did this in class, so I got that voltage to be about 1.7 volts. And we'll need to find what the current was, and the current was about 0.85 amps. But we want to find what the current is in the RTD, so we can just use Ohm's law again, and using a multimeter, I found what the resistance was, and I got my current to be about 0.0016. So you might be asking yourself, why do we need current? Well, our RTD helps us to get these voltage readings. However, this assignment is asking us to track temperature versus time. So how can we relate those? We're actually taught in this course an equation where temperature and resistance have a linear relationship, and it looks something like this formula. We already know the current, we are constantly recording that voltage every minute, and we have Ohm's law. So we can kind of manipulate this equation to look like this with all the values we have. And in our code specifically, it would look something like this. Moving on to the actual visuals of the circuit, I'll show you guys what it is with the real kit in my hands, but I just want to draw this small schematic for you guys so that in case my video is not clear enough, you can just pause this at any time and check back to see if your circuit works. Okay, so I'll show you guys how to make the circuit, but for demonstration's sake, pretend that this is a male-to-male connection, because all of my male-to-male connectors and the RTD and the school-provided Arduino are over there collecting some temperatures for me right now. But I do want to show you guys how to make the circuit, so I'll just show you with what I have. You're going to want to connect to 5-volt input. There. And put this into your breadboard on the positive side. Then you of course want to connect something to ground, which is right beside the input. And this one goes to the negative terminal. Now, to get into your actual circuit, you're going to want to put something at the power supply and sort of put it far out. And we're going to be connecting this circuit in series. So these 2 resistors, when put in series, their sum is the total resistance. Put it along the same line and spread it out a little bit. Then again along the same line and just put it out. And that's sort of what it should look like. Then along that same line as your resistor, gonna put another pin and plug that one into analog. This one is for the purpose of recording your voltages, and that comes up in the formula, and I'll show you guys that in my code. Then just taking something far out, and I know it's an incomplete circuit, but here and here are where the connections to the RTD would go. And then this pin would just go to the negative side to fully complete that circuit. There you have it. This is the final circuit. I just put the male pins over there where the circuit was kind of open before. And they're connected to the RTD, which is safe in its plastic bag. Don't worry, it's not touching that salt ice. You can see the connection straight to my laptop, and there we go, our first reading, about -2 degrees. And this is the code. It's basically giving us the voltage value. However, we want to convert it to temperature, and that's exactly what this equation is doing. We're plotting it, getting the values, and I've done this run with pure water already, so this is what those values kind of came out to be. I used different volumes of water just to see if that made a difference, and that's sort of what the graph looks like right now. So give it about 4 hours and then we'll get our own data for the salt water too. Just a bit of an update. I started this experiment around 4:40 and it is now 8:11 so just about half an hour to go. The water looks very much melted already, and you can kind of see that in the temperatures. I think that this reading is quite interesting compared to water because it took a long time for it to finally like pass that threshold of its freezing point. And with water, it kind of plateaued around like 5 degrees, but this one keeps on getting a little bit warmer. So we're at 12, so I don't know if it's gonna change much in the next half hour, but if it does, I'll keep you guys updated. So it's about 8:50 now and my program just stopped running, so I have all the data I need. I put it into Excel and this is the graph in comparison to pure water. I have a lot to unfold about this. I'm not gonna do it in this video, but at least we know that we got the results we were looking for. Now that I've been inside for like 4 hours, I think I'm gonna go crazy. So I'm just gonna go for a quick walk somewhere around campus so that I don't go insane. Anyway, I hope you guys like this, and I hope you guys like the future chem eng vlogs to come.